From an early age, what comes out of the ground can fascinate us.
This rock is lighter than it looks.
We could use it as a phone.
Actually looks like it's got gold, a little bit glittery. Looks a bit like treasure.
And perhaps that's just what it is for all of us.
Some rocks contain significant amounts of metals that are economically valuable. We call these rocks ores. The ore is recovered from the earth through multi-stage mining and is then processed. Ores provide important raw materials such as copper, iron, and nickel that are paramount for our modern life and the manufacturing of industrial goods. Copper is a metal that has been mined for 10,000s of years. It belongs to the group of important materials that secure the development of civilization. Different from traditional mining, the BIOMOre project focuses on a novel extraction technique for copper and also critical raw materials and metals as regularly defined by the European Commission, such as antimony, germanium, gallium, platinum group elements, rare earth elements, and other are defined as critical raw materials because of their strong economic importance and significant supply risk. They occur in and are today indispensable for a wide variety of existing and even new technologies that affect our daily life, like smartphones and other electronic devices, cars, airplanes, but also magnetic refrigeration, fuel cells, or water treatment. Today, ore deposits close to the surface are mostly exploited in Europe. Therefore, the European Union is largely dependent on import of raw materials from outside Europe to meet its economic and industrial demands. To reduce this dependency, former inaccessible deposits at large depths exceeding 1,000 meters are now the focus of our attention. The BIOMOre project will develop a new technological concept for the environmentally sustainable in situ extraction of economically important metals such as copper and zinc. The project is initially designed for 3 years and is funded by the European Horizon 2020 Innovation and Research Programme with a budget of €8.4 million.
BIOMOre project is a project introducing a new concept in mining, combining, investigating the combination actually of hydrofracturing and bioleaching in order to provide a sustainable idea of environmental friendly mining and winning of the ores using the two concepts together. It's a very challenging project and the Commission is funding this work in order to fulfill and answer the questions of sustainable supply and access of raw materials for the European continent, and ultimately introduce new productive, environmental friendly ways of mining in Europe and boost productivity and growth for everybody.
The BIOMOre partners bring state-of-the-art scientific and technological competence to the project. BIOMOre's experts are from all over Europe, Canada, and the Republic of South Africa. Methods and procedures will be tested and evaluated in laboratories and an underground test facility in an operating mine in Poland. We are combining hydraulic fracturing to enhance the permeability and porosity of the ore with novel in situ bioleaching methods. In situ tests will be performed underground at an isolated 100 cubic meter ore block. This is how the BIOMOre underground tests will run. The bioleaching solution will be produced in a tank with the help of specialized microorganisms. The solution that is generated will be pumped into the ore block where the metals will be dissolved. After this, the solution, including the dissolved metals, will be sucked off the rock, conventionally processed for winning the metals, and returned to the tank with the microbes to be regenerated. Analyses of the leaching results will determine the parameters for a potential future full-scale process. A possible setup in the near future could look like this. The ore body will be accessed through state-of-the-art deflected drilling technology. In continuation, the boreholes will be connected via blasting, hydraulic, or gas fracturing. This is in order to increase the amount of channels for the leaching solution to penetrate the ore body and to maximize the reactive surface area. Our environmental responsibility obliges us to comply with the strict environmental and safety standards of the European Union, today and in the future. The advantages of this new method are obvious. Safe, ecological, and economical use of ore deposits located deeper than 1,000 meters, less infrastructure above ground, largely reduced mine waste dumps and thus lower impact on environmental receptors, creation of new jobs in mining and mineral processing in Europe, and less import dependence of Europe for raw materials. Knowledge transfer is here. Join us at biomore.info.